In your careers, you're not just going to be judged on the problems you solve, but on the ones you prevent from ever happening. Today, we're going to give you a new way to think, a kind of X-ray vision for supply chains. We're going to pull back the curtain and look at the hidden forces that really drive success and failure. This is about moving you beyond just reacting to crises and toward designing systems that are built to last. All right, let's start with a puzzle that haunts pretty much every manager. You know the feeling, you put out one fire and suddenly two more ignite somewhere else. A small delay from a supplier, a minor stockout. Why do these everyday headaches sometimes spiral into these full-blown catastrophes? Well, the answer, as we're about to see, isn't in the events themselves, it's hidden in the invisible architecture of the system. So, here's our roadmap for today. First, we'll learn to look past the daily chaos to see the deeper patterns. Then, we'll get under the hood and look at the engine of every system, feedback loops. We'll figure out the difference between those powerful spirals and the stabilizers that keep things in check. We'll expose a really common short-term trap, and then finally, we'll equip you with the toolkit you can actually use. The end goal here is not just to play the game better, it's to actually change the rules of the game itself. Let's dive right in. The first shift in how we think is probably the most important. You see, most managers spend their days treating symptoms. Reacting to a stockout, for instance, is like taking a painkiller for a toothache. Sure, it helps for a little while, but a systems thinker, well, they're the dentist. They look at the inventory policies, the demand forecasts, the supplier lead times to find and fix the underlying cavity. We're moving from just managing symptoms to finding a real cure. Okay, so if we're not just gonna react to daily events, what are we supposed to be looking at? It's time to look under the hood. What's the engine that's actually driving all this complex behavior? The answer is something called a feedback loop. But before we can get to loops, we've got to quickly define the system they live in. So on the slide, you see the formal definition, a set of interconnected parts working toward a common purpose. Honestly, the most critical word there is interconnected. Your supply chain isn't just a straight line from point A to B to C. It's a dynamic web. An action in one part, let's say a factory ramps up production, it sends these ripples that are felt everywhere, from the raw material suppliers all the way to the final customer. And the mechanism that drives this whole web of cause and effect is the feedback loop. Like the slide says, this is where the result of an action circles back to influence that same action down the road. It's a cause and effect chain that isn't a straight line, it's a circle. Let's look at a really practical example to make this crystal clear. This is where we really separate reactive management from systems thinking. A linear thinker just looks at the event on the left, low inventory caused to stock out. Problem, reaction, done. But no, a systems thinker follows the arrows. They see the reaction. Managers get nervous, they lower their sales forecasts, and so they order less, which leads, inevitably, to the cycle. Ordering less guarantees you'll have even lower inventory in the future. It becomes a self-fulfilling prophecy. That is a feedback loop. Now that we know what a feedback loop is, we can get into its two fundamental forms. And these are the two forces that govern the behavior of every single system you will ever manage. You can think of them as spirals that spin things out of control, sometimes for better, sometimes for worse, and stabilizers that work to keep everything in check. So on the left, we've got reinforcing loops. And just like the name says, they reinforce a direction of change. The best way to think of them is like a snowball rolling downhill. They amplify small changes into either exponential growth or a really steep decline. On the right, we have balancing loops. These are your control systems. Think of a thermostat in a room. They are always working to bring a system back toward a specific goal, a state of equilibrium. Now, a reinforcing loop that works in your favor is called a virtuous circle, and it is the absolute dream of every company. Imagine a successful product launch. More sales create more happy customers. Those customers then generate positive word of mouth, which drives even higher demand. This, in turn, leads to, you guessed it, more sales. The growth literally feeds on itself. It's an amazing thing to see. But these reinforcing loops can also be vicious cycles. And the most famous example in our field is the Bullwhip Effect. It all starts with a small, unexpected bump in customer sales. The retailer sees this and places a slightly larger order with their distributor, just to be safe. The distributor sees that larger order and, also trying to be safe, places an even bigger order with the manufacturer. You see what's happening? A tiny ripple at one end becomes a massive disruptive wave all the way up the supply chain. Now let's look at the other type of loop, the balancing loop. I like to call it the unsung hero of stability. Take a look at this simple process for inventory management. First, there's a problem. Your inventory drops below your target. This triggers an action. You place a replenishment order. And finally, the outcome. A new shipment shows up and your inventory returns to its target level. This constant cycle of correction is the fundamental control system that keeps your business running smoothly day in and day out. So now that we understand these two forces, the spirals and the stabilizers, we can see how they can lead to a really common management trap. This is a pattern where a smart, well-intentioned short-term fix ends up creating disastrous long-term consequences. It's a classic archetype called the fix that fails. The absolute key to this trap is the time delay, which you can see laid out on this timeline. A manager is facing high transportation costs. The quick fix in month 1 is to switch from expensive air freight to cheap ocean freight. And immediately, costs go down. That manager looks like a hero. But notice the delay. By month 3, the hidden consequence starts to pop up. Supplier lead times have tripled. And by month 6, the real disaster hits. The now sluggish supply chain can't react to demand shifts. Stockouts are surging, customers are leaving, and the total cost of that fix is way, way bigger than the initial savings.
So the big question is, how do we avoid falling into these traps? How can we develop the foresight to see these hidden consequences before they happen? Well, it requires a different way of analyzing problems. Let's build your systems thinker toolkit with 3 core principles.
Okay, this first principle is absolutely critical. You have to separate correlation from causation. Just because 2 things are happening at the same time, it doesn't mean one is causing the other. Think about the question on the slide. You notice that when warehouse staffing is high, the rate of damaged goods is also high. So does having more people around actually cause more damage? Or is it maybe more likely that a third factor, like a huge sudden surge in shipments, is the true root cause that both forces you to hire more staff and leads to rushed, error-prone work? If you focus on the symptom, the staff levels, you will never solve the real problem.
Our second principle requires us to see the business in a new way by distinguishing between stocks and flows. A stock is simple. It's just an accumulation of something at a specific point in time. It's a snapshot. So the 5,000 units you see right here, that represents the inventory currently sitting on your warehouse shelves. That is a stock. But honestly, by itself, this number tells us very little. To actually understand that stock, we have to analyze the flows. A flow is the rate of change. As you can see, we have an inflow, our inbound shipments, arriving at a rate of 1,000 units per day. And we have an outflow, customer orders, leaving at 800 units per day. Now that number from the previous slide makes sense. Our stock of inventory is actually growing by 200 units every single day. Looking only at the stock is like looking at a single frame of a movie. You have to analyze the flows to understand the whole story.
The third and final principle in our toolkit is all about defining the rules of the game. When you analyze any system, you're dealing with 2 types of values. First, there are parameters. Think of these as the fixed control knobs that you can set. As the table shows, a supplier's lead time might be a parameter that you set at 15 days. Then there are variables. These are the numbers that change as a result of the system's operation, like the inventory shortfall, which is constantly being recalculated based on the gap between your target and your reality. And this brings us to the ultimate goal of a systems thinker. You see, it's not enough to just analyze the system or to play the game more efficiently. The highest leverage point for improvement comes from changing the fundamental rules of the game itself. This is where truly lasting change happens. The most powerful solutions don't come from working harder. They come from changing the underlying structure. Let's go back to that bullwhip effect. A company suffering from it probably has a decision rule somewhere that says, base our factory schedule on the size of today's incoming orders. Well, that rule pretty much guarantees volatility. A systems thinker intervenes at the structural level. They change the rule itself to something like, base our production on a 4-week rolling average of actual sales to the end customer. That single change in the system's rules can eliminate the bullwhip and stabilize the entire supply chain.
So, as we wrap up, let's lock in the 3 key takeaways from today. First, learn to see your supply chain not as a simple line, but as a dynamic system of reinforcing and balancing loops. Second, develop a deep respect for time delays. Always be asking, what are the hidden long-term consequences of this quick, short-term fix? And third, always diagnose before you act. Separate cause from correlation and analyze the stocks and flows to get a true picture of what's really going on.
I'll leave you with a final question to take with you. As you go about your week in your part-time jobs or even just observing the world around you, I want you to look for a system in action. And then ask yourself the question on this slide. What is an obvious fix right here that might have a hidden, unintended long-term cost? Developing the habit of asking that question, that's the first real step on the path to becoming a true systems thinker.